Hello, everybody. My name is Gierad Laput. I am a PhD student at the Human-Computer Interaction Institute here at Carnegie Mellon University. Let me start by stating that this is mostly where Amazon Alexa is implemented right now. So if you take a step back, this is the vision of what we call ubiquitous sensing in smart environments. People have sought this for a long time. Lots of people have worked hard on trying to realize this goal. So today, such efforts fall under the names like smart home or, more commonly, the Internet of Things. But regardless of these different names, the goals have remained the same over decades. That is to apply sensing and computation to enhance the human experience, especially as it pertains to physical contexts like this and the amenities within that space. So with this type of data, users can stay informed and developers can create smart and responsive applications that enhance people's daily routines. Okay, there are two ways to achieve this vision today. One is to upgrade one's home with smart appliances, smart microwaves, smart dishwashers, smart coffee makers, and on and on. But these are expensive and rarely talk to one another because instead of working together, they form silos of smartness because they're built by different manufacturers. A more flexible option is for owners to tag existing facets with aftermarket sensors. But this adds some level of smartness but requires many tags. So it requires periodic recharging and also socially and aesthetically obtrusive. There's lots of these things. What if we could use a single highly capable sensor board that can indirectly monitor an entire room? Is this possible? And how far can we take this idea? So we surveyed a bunch of sensors in commercial and academic systems. And for our hardware design, we decided to include all of these sensor facets, but no camera, as this is particularly sensitive to users. So here's our eventual hardware design and the low-level sensors that we include. This incorporates 9 physical sensors able to capture 12 distinct sensor dimensions: vibrations, acoustics, electromagnetic noise, temperature, humidity, barometric pressure, illumination, light color, magnetic field, radio interference, and directional heat. Our sensor board is plug and play, uses wall power, and connects to the cloud backend over Wi-Fi. So you plug it in like that. Here's the kicker. A single board in a room can capture a wide variety of events. And to show that, here's some example context. In this kitchen, we can detect the faucet running. And this is just one sensor board. You can see like right there, it's plugged in, just one board, right by near the faucet. We can detect that the blender is on. You can see there's machine learning running in here. And right across the street, we can detect the coffee grinder is on. And also when the burner is on. So we use all these different versatile sensing capabilities to see that the burner is on. But it's not limited to that. If you plug this into a bathroom, we can detect the shower, the 2 vanity faucets, left versus right, several bathroom accessories, the toilet flushing, or when the light is off. We can also detect multiple events in the house, including when the fireplace is on, when the water tank is heating, when the dryer is running, when the HVAC is on. In a workshop or industrial setting, we can detect multiple events, such as when the dust filter is running, when the exhaust fan is on, different tools, such as saws, different things in industrial settings, vacuums, drill press, grinders, different hand tools. All these things we can detect with one device. In an office, we can detect a suite of events, such as a door knock, a door closing, a phone ringing. We can detect when someone is writing on a whiteboard or when someone is erasing on the whiteboard. And then we can detect when people are using the water fountain, in the urinal, or when they're paper towels are dispensed. Lots of different things. But what's interesting to users is that we call this first-order synthetic sensors, but you could go a level higher than that, which we call second-order synthetic sensors. So here's an example. Instead of detecting when the paper towel is dispensed, we could add an abstraction where we can detect count. So here's an example. Look at this guy. That's actually me. When you take the paper towel up, we could detect that there's one. So you count down, and you do another one, and then you count down and it says, hey, you're running low. I'm going to send you an email and say, hey, facilities, auto-update and buy something in Amazon. Right? You get an email. If you run the faucet continuously, you can detect the duration and the volume of water that's being used. And so you can have things like know how much water is being used, and you can compete with your neighbors and save some water and energy, et cetera. Finally, we can detect different states. Lots of objects have different states. For example, this microwave, we can detect when it's open or closed. when it's chiming and when it's running. And then the cool thing about this is you can have like a complex state machine able to track the different functionalities of these devices. I'm running out of time, but just to say, there's no stopping at second order sensors. You could go nth level sensors where you could have all these complex events and activities that you can detect just from one single device. Isn't that pretty cool? Thank you.
Okay, same questions I asked the first team. A, do you have a prototype?
I do have.
Throw that in there, but that could be fake.
Oh,
device.
I just demoed this actually 2 days ago.
Okay.
I was going to bring it with me, but since we don't have access to this laptop, if you want, you can go to my lab today. I can show it to you.
I'll look.
Okay.
Second, where's Alexa?
Where's Alexa? That's a great question. I've been thinking hard about this. The cool thing about Alexa is that it's in the home. This Alexa is the beachhead for this type of technology. You can imagine Alexa right now is voice powered, but if you imagine Alexa having this type of capability, not only can you have input as voice, you have all these other things incorporated in Alexa.
So I got a couple of questions. First, is the dominant sensor in those examples you showed sound?
That's a great question. So we have a paper that details all of these things. The dominant sensors comes from 3 sources. One is microphone, of course, but you'll be surprised that there's a lot of events in accelerometer. The special thing we did with the accelerometer is we went from 100 hertz to 4,000 hertz. And if you go 4,000 hertz, you get this very interesting thing. We can detect micro vibrations. We can detect micro vibrations in the plumbing. We can detect micro vibrations when someone is opening the door and closing the door. All these different micro vibrations from tools. That's the key thing. And because they're accelerometer based, they're not susceptible to noise when people are clapping and all these different things. We have all other facets that we can sense to make sensing more robust.
How many do you think you'd need to deploy across a home to sort of, or even in the kitchen example, to do all those
from
things?
our studies, 1 sensor per room is the ideal. 1 per sensor per room or less, because it turns out some sensors can help each other. They can help figure out, because they can be related, that they can increase the sensing range. They help together. So the ideal cases is 1 sensor per room.
And how do you think about this as compared to approaches that are looking at, and there's a number of companies doing this, that are looking at tapping into the electrical grid in the home and sensing when an appliance is on, that they get a unique signature of the power consumption of that particular device. So have you thought of that sort of approach as an alternative to what you guys are doing?
So we thought about that. Actually, we haven't seen that work. Yeah. It's very hard to get those things to work. Yeah. And then the other thing is that we have that kind of sensor. It's called the electromagnetic interference sensor that we have in here. So we have that capability if we need to. This is an extension of lots of different projects put into one board. And so we have that capability too.
Cool. And the last question is, so what? Meaning you're able to synthesize all this data and know that your faucet is running X amount of time. What does a person do with that?
So I'm not going to speak for myself. I'm going to speak to all the people who emailed me. Procter & Gamble, Nestle, people in farming industries, people in construction industries, people in restaurant businesses and all these different things. Those guys have thought about what to do with it, so that speaks for itself.
Got it. So you envision being sort of an enabling technology?
I could be an enabling technology. We could make money by getting licensing, or we've already built 100 of these boards, so we could also mass produce this. We can make money off of that too. So that's another possibility.
Very cool.
Thank you.